Welcome back, listeners, to the Operating Systems Crashcast. I'm Victor, and with me, as always, is the brilliant Sheila. Today we're wrapping up Chapter 1 with a comprehensive summary of everything we've covered so far. Sheila, let's dive right in.
Absolutely, Victor. We've covered a lot of ground in this chapter, so let's start with the basics. Can you remind our listeners what an operating system actually does?
Great question, Sheila. At its core, an operating system is like the conductor of an orchestra. It manages all the computer's resources, from hardware to software. It acts as an intermediary between user applications and the computer hardware, providing a user-friendly interface while efficiently allocating resources.
That's a great analogy, Victor. And speaking of the computer itself, we've learned about computer system organization and architecture. Could you highlight some key points?
Certainly. Modern computer systems typically have multiple CPUs or processor cores. They use various storage devices organized in a hierarchy, from fastest but most expensive, like CPU registers, to slowest but cheapest, like magnetic disks. We also discussed how interrupts are crucial for efficient I/O handling, allowing the CPU to work on other tasks while waiting for slower I/O operations to complete.
Excellent summary, Victor. Now, let's move on to the structure and operations of operating systems. What are some key takeaways?
Operating systems can have various structures, but a common one is the layered approach. As for operations, we learned about multi-programming and time-sharing, which allow multiple programs to run concurrently, improving CPU utilization. We also discussed how operating systems use dual-mode operation, user mode and kernel mode, to protect system integrity.
That's crucial information, Victor. Now, let's talk about some of the core management functions of an OS. Can you elaborate on process and memory management?
Of course, Sheila. Process management involves creating and deleting processes, providing mechanisms for process synchronization and communication, and handling process scheduling. Memory management, on the other hand, involves keeping track of which parts of memory are in use, allocating and deallocating memory space as needed, and deciding which processes to move in and out of memory.
Excellent explanation, Victor. We also covered storage management, which is equally important. Could you briefly touch on that?
Certainly. Storage management involves file system management and mass storage management. The OS provides a uniform, logical view of information storage through the file system, abstracting from the physical properties of storage devices. It's responsible for free space management, storage allocation, and disk scheduling, among other tasks.
Thank you, Victor. Now, in today's digital age, protection and security are more important than ever. What did we learn about these aspects?
You're absolutely right, Sheila. Protection refers to mechanisms that control the access of processes or users to the resources defined by a computer system. Security, on the other hand, defends a system from external and internal attacks. These include user authentication, defending against outside attacks like denial of service attacks, and ensuring data integrity.
That's a crucial distinction, Victor. We also discussed kernel data structures, various computing environments, and open-source operating systems. Any final thoughts on these topics?
Indeed, Sheila. We learned that operating systems use many fundamental data structures like lists, stacks, and queues. We explored different computing environments from traditional to mobile, client-server, peer-to-peer, cloud, and real-time systems. Lastly, we touched on the significance of open-source operating systems like Linux, which have greatly influenced OS development and adoption.
Excellent summary, Victor. As we wrap up this chapter, what would you say are the most critical takeaways for our listeners, especially if they're preparing for interviews?
Great question, Sheila. I'd say the key points to remember are 1. The definition and core functions of an operating system. 2. The basic components and organization of computer systems. 3. The importance of process and memory management. 4. The concepts of multiprogramming and time-sharing. 5. The distinction between protection and security in OS. These concepts form the foundation of operating systems and are likely to come up in technical interviews.
Thank you, Victor. That's a perfect recap. And with that, we conclude our summary of Chapter 1. Listeners, We hope you've enjoyed this journey through the fundamentals of operating systems. Stay tuned for our next episode where we'll begin exploring operating system structures in more depth. Until then, keep your systems running smoothly.
Thanks for listening, everyone. This is Victor signing off.